gentlemen. This is section 2.3. We're talking about applying what is called deductive reasoning. So up until this point, we've talked about if-then statements, our conditional statements, and we've also talked about inductive reasoning. Today we're going to talk about deductive reasoning. So a review of inductive reasoning is that it uses examples and patterns, and we use those to form conjectures. So for an example, if we take a number pattern, 1, 3, 9, and 27, we see that we're multiplying by 3 every time so we can predict or make a conjecture. The next term is going to be 81. And so that is an example of inductive reasoning. Deductive reasoning, however, doesn't use patterns. It uses facts, definitions, accepted properties, and the laws of logic, and we'll talk about 2 laws of logic today, to form logical arguments. And we'll go through several examples of deductive reasoning. That's why it's not located under here as it was for inductive reasoning. So let's start with those laws of logic. We're going to start with one law of logic, which is the law of detachment. So let's look at the law of detachment in 2 different ways, or rather from 2 different perspectives. First of all, if the hypothesis of a true conditional statement is true, so if the hypothesis is true, then the conclusion is also true. And so if we look at it with symbols instead, we look at it as if A, then B is our conditional statement. A is our hypothesis, B is our conclusion. A is true, therefore B is true. Or another way to look at it is if A occurs, then B must also occur. So that is the law of detachment. If A occurs, then B also occurs or is true. So for a couple of examples, using the law of detachment, the directions say to make a valid conclusion for the true situation. So since we're going to make a valid conclusion, we're going to write a conclusion. So for part A, if 2 segments have the same length, then they are congruent. You know that the length of BC is equal to the length of XY. Well, first of all, our hypothesis, or our part A, is 2 segments have the same length. Our part B, our conclusion is they are congruent. So if A is true, then B is true. So let's see for the next piece. You know that the length of BC is equal to the length of XY. Well, that is saying the 2 segments have the same length. So that is part A. If these 2 segments have the same length, then using the law of detachment, the conclusion must also be true. They must be congruent. So if we know that these 2 segments have the same length, our hypothesis is occurring, then the conclusion must also occur. These 2 segments must be congruent. So our hypothesis, they have the same length, occurred. So our conclusion, they are congruent, must also occur. That is the law of detachment. Something you're probably more familiar with than using it with algebra or geometry. For part B, Mary goes to the movies every Friday and Saturday night. Today is Friday. So Friday and Saturday night is our condition. So that's our hypothesis, that is A. Mary goes to the movies. That is our conclusion. That is based upon the condition that it's Friday or Saturday. So that is our part B. So if it's Friday or Saturday, our condition happens, then Mary must go to the movies. Our next sentence says, today is Friday. Part A is occurring. It is Friday or Saturday night. Therefore, we can conclude that Mary is going to the movies tonight. Movies tonight. So again, if our hypothesis occurs, then our conclusion must also occur. Since our hypothesis does occur, it is Friday or Saturday night, our conclusion must also occur. Mary is going to the movies tonight. So that is law of detachment in its simplest form. Again, feel free to pause, rewind, relook through these, ask me questions in class. I'm in my room at 7:30 if you want to ask any questions. After school, Mondays and Wednesdays till 5:30. Let's look at our second law, the law of syllogism, showing my favorite commercial. And let me make sure again, I always forget to do this, that my audio is correct. Let's see here. Yes, it is. My favorite commercial, hopefully the audio comes out okay.
When your cable company keeps you on hold, you get angry. When you get angry, you go blow off steam. When you go blow off steam, accidents happen. When accidents happen, you get an eye patch. When you get an eye patch, people think you're tough. When people think you're tough, people want to see how tough. And when people want to see how tough, you wake up in a roadside ditch. Don't wake up in a roadside ditch. Get rid of cable and upgrade to DirecTV. Call 1-800-DIRECTV.
Favorite commercial. Now, this commercial actually demonstrates what we know as the law of syllogism. The law of syllogism says this: if you have two conditional statements, if A then B, and if B then C, where one conclusion is the same as the other's hypothesis, then we can cut out the like pieces and conclude that if A, then C, kind of getting rid of this middle. So that's what this commercial did. If you keep cable, then you will be on hold. If you're on hold, then you will get frustrated. If you get frustrated, you will blow off steam. If you blow off steam, accidents happen. If accidents happen, you get an eye patch. If you get an eye patch, people think you're tough. If people think you're tough, they want to know how tough. And if they want to know how tough, you wake up in a roadside ditch. So they're saying that if you don't get rid of cable, you're going to end up in a roadside ditch. They cut out the middle pieces that were the same and left the beginning. If you have cable, and the conclusion, you'll end up in a roadside ditch. So we're cutting out the pieces in the middle. Well, obviously, there's a lot of loose logic in that reasoning because a lot of those things don't necessarily mean the other is going to happen because all those conditional statements are not necessarily true conditional statements. So let's look at some examples that we can go through. We'll look at 3 of them. First of all, the directions, if possible. So some of these won't be possible. Use the law of syllogism to write a new conditional statement that follows from the pair of true statements. So for part A, if Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. So we see that one conclusion matches the hypothesis of the other. So we can eliminate those two and just leave our original hypothesis and our ending conclusion. So if Rick takes chemistry this year, so I'm just going to abbreviate and say if chem, then Rick will get an A in chemistry. So then Rick will get an A. So then Rick, and I'll just say A. You should write with proper grammar the entirety, but in order to keep this video nice and short, I'm going to go ahead and abbreviate. So if chemistry, then Rick gets an A. That's eliminating the middle piece. If he takes chemistry, Jesse will be Rick's lab partner. If Jesse's his lab partner, Rick will get an A. So we can just say if he takes chemistry, we know he's going to get an A and cut out the middle piece. So that is one example of law of syllogism. Let's look at one involving algebra. So for part B here, if x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. Some people would look at this and say you can't use the law of syllogism, but here we can because one hypothesis matches the other's conclusion. What we're not used to is this order. It's more familiar if we were to switch the order here. So if x is greater than 5, then x squared is greater than 25. If x squared is greater than 25, then x squared is greater than 20. That's what we're used to seeing. So we see that the conclusion, the hypothesis are the same, so we can cut them out and just say if x is greater than 5, then x squared is greater than 20. So again, as long as one hypothesis matches another's conclusion, you can use the law of syllogism. In this case, we're more familiar, though, with seeing the order reversed. We're seeing conclusion, hypothesis, like this. So that's part B. So we could use it for part B, although some people would think no because the order of the sentences. You can swap the order of the sentences in this case. Now, for the next one, let me erase this first. For this particular problem, if a polygon is regular, then all the angles in the interior of the polygon are congruent. We know that from section 1.6. If a polygon is regular, then all of its sides are congruent. The problem with this one is that one conclusion does not match the other's hypothesis. Both hypotheses are the same. So that is a problem. So since both hypotheses are the same, not a hypothesis and a conclusion, here we cannot use the law of syllogism, so this is not possible. Our answer, we would simply write possible if it were a fill-in-the-blank assessment. For my multiple choice assessment, then you would choose the option that says not possible. All right, we're not going to go through that one, but let's look if we can state what law of logic is being used for these couple of examples. For number 3, if you get an A or better on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. So our conclusion, if you get an A or better on your math test, then you can watch your favorite actor. The answer is the law of syllogism, because you have one conclusion matching the other hypotheses, and for their conclusion, they crossed out the They crossed out the shared piece and kept the two pieces that were left. So if you get an A on or better on your math test, then you can watch your favorite actor. Law of syllogism. For number 4, if x is greater than 12, then x plus 9 is greater than 20. Okay, makes sense. The value of x is 14. Conclusion, therefore, x plus 9 is greater than 20. This is the law of detachment, which says if your hypothesis occurs, x is greater than 12, which occurs here, then your conclusion must occur. So x plus 9 must be greater than 20. That is our law of detachment. That concludes our notes for section 2.3. It's a short video. Hopefully this is helpful, and hopefully it'll help you prepare for your quiz or test or whatever it is that you're hoping to get from this video.